Hello everyone, welcome to Math World. This video is to discuss the questions from numerical method, which is the topic from paper 3. Okay, so let's start with question number 1. So, given a curve with equation y equals to 4x plus 2 multiplied with tangent 4x. So the curve has a turning point at A with the x coordinates of alpha. So A shows that alpha satisfies the equation sine 8x plus 4 equals to 0. Okay, so whenever you see the turning point, this will be dy dx equals to 0. Okay, so now which means we need to perform the differentiation. So y equals to 4x plus 2 multiplied with tangent 4x. This is the A. So then use the product rule, u equals to 4x plus 2, and then the v equals to tangent 4x. So the u prime, differentiate 4x plus 2 is 4, differentiate v is, differentiate tangent, I get secant squared, rewrite 4x, differentiate 4x is going to be 4. Okay, the product rule formula is differentiate uv equals to uv prime plus vu prime. Therefore, by applying this formula, you will be getting dy over dx equals to 4x plus 2 multiplied with 4 secant squared 4x plus tangent 4x multiplied with 4. Okay, then from here, the common term is the 4. So factorize the 4. You will have multiplication of these two terms. That is 4x plus 2 multiplied with secant square 4x plus tangent 4x. And since there is a turning point when x equals to alpha, so I will just write dy dx equals to 0 when x equals to alpha. Okay, which means now here I have to replace my dy dx by 0 and my x by alpha. So I will write 0 equals to 4 times 4 alpha plus 2 multiplied with secant squared 4 alpha plus tangent 4 alpha. Okay, and then from here, I can just divide the whole equation by 4, which means just direct ignore the 4. Okay, because when you move the 4 to the left side, 0 over 4 is still 0. So I will be getting 4 alpha plus 2. So for information, this secant squared 4 alpha means 1 over tangent squared 4 alpha. Okay, and now when you look at the question over here, we need to get sine. Therefore, the tangent 4 alpha will be replaced, will be expressed in the definition, which is sine 4 alpha over cos 4 alpha. Then equals to 0. So now I can combine. Okay, oh sorry, there is a mistake. The secant square is 1 over cos squared. Okay, so now I will combine both denominators. So when I combine both denominators, my first term is 4 alpha plus 2. Then second term is have to times by cos 4 alpha for the numerator and denominator in order to get the cos squared 4 alpha. Therefore, I will be getting sine 4 alpha cos 4 alpha. Then equals to 0. So now here, when I need to simplify, basically when you move the cos squared 4 alpha to the right side, it's still 0, which means I will just consider the numerator. So now I'm getting 4 alpha plus 2 plus sine 4 alpha cos 4 alpha equals to 0. But then now when you look at the question over here, you only get sine 8x. Okay, that means now I should have to get sine 8 alpha from the equation. So if you have sine angle times cos angle, that is double angle formula, because this can be expressed in sine double of the angle, which is sine 2a equals to 2 sine a cos a. So now my a is 4 alpha. Okay, so my a is 4 alpha. That means my 2a is going to be 8 alpha. So from here, now if I get this as a subject, so sine a cos a is going to be half sine 2a. Okay, and replace the 2a by 8 alpha. That means now you will be getting half sine 8 alpha. And now to eliminate the half, so times 2 for the whole equation, that will be 8 alpha plus 4 plus sine 8 alpha equals to 0. And now here, just rearrange sine 8x. So here becomes sine 8 alpha plus 8 alpha plus 4 equals to 0. So I will just write x equals to alpha satisfies the equation sine 8x plus 8x plus 4 equals to 0. So I have shown the equation. Okay, now B, verify the x coordinates of the point A lies between -1 and 0. So we have to solve this using sign change rule. Okay, verify means show by replacing a value. So we refer back to this equation because your alpha is actually the x coordinate of the point A. So I will just write sine 8x plus 8x plus 4. Okay, and let this be fx. Then replace the x value by -1. Replace the x by -1. So f -1, that is sine 8 plus 8 plus 4. So when you do calculation, remember this sine 8, that means the sine 8 without degree sign, that is radians mode. Okay, so change, sorry, -1. So this is -1. Here is going to be -8. Okay, so now change the mode of the calculator into radians first before you do calculation. Therefore, you will be getting -4.9894, and now I round up to 3 significant figures. So therefore, -4.99. This is less than 0. And now I replace the x value by 0. So f0, it will be sine 0 plus 0 plus 4. So sine 0 is 0, therefore end up with 4. And 4 is greater than 0. So just right here, since f -1 less than 0 and f0 is greater than 0, there is a sign change. Okay, hence alpha, or the x coordinates, I would say, hence the x coordinate, which is our alpha of the point A, lies between -1 and 0. Okay, so done for this part. Now C, use the iterative formula. Okay, this is a formula to approximate the value of alpha equal to 3 significant figures and give the result of each iteration to 5 significant figures. So xn plus 1 equals to -1/8, 4 plus sine 8xn. So now the initial value of x is not given, which means the x0 is not given. But then from the previous calculation, we know that it is between -1 and 0. So you can choose any values of x in between -1 and 0, or could be exactly -1 and 0. Now I will just pick the middle value. So which means I will pick -0.5. Okay, so then I will be getting x1. So replace the x. Now when you let your n be 0, the left hand side is x1. The right hand side, the xn becomes x0. So you just replace the x0 by -0.5. And remember to do the calculation in radians mode. So it will be -0.59460. 5 significant figures. And then now here, From 0.5 change to negative 0.59460, there is a big gap. Therefore, we have to continue the iteration process. So just replace the x by the latest x value that you have just found. Then here is going to be negative 0.62488. So now you check here. At first, three significant figures. They are different. Therefore, you have to continue. Okay. So here I will be getting this calculation. Then this will give you negative 0.61990. Again, they are different. Okay, so then x4 so I will be getting negative 0.62121. Okay, still different values. So I need to get identical three significant figures. So I need to continue for one more step and check. Then this is going to be negative 0.62089. Okay, so just now 621. Okay, when you look at here, 621, now becomes 620. So probably I will just find one more to double confirm the value. Because the previous one, if you round up, I'm getting 621 as well. So negative 0.62089. And this is going to be negative 0.62097. Okay, so here I will stop. Right, because these three are the same. Now, if you round up here, you get 621. If you round up the previous one, 621. So it's same as the previous one. So it means that I'm confirmed that my alpha value, okay, this is my alpha. Alpha approximates to negative 0.621. So this will be the solution of this question. Okay, now next question, number 2. By sketching a suitable pair of graphs, show the equation cotangent x plus x squared minus 4 equals to 0 has a root in the interval x between 0 and half pi. Okay, so now to get a suitable pair of graphs means that you need to sketch two graphs on the same diagram. So I will write cot x plus x squared minus 4 equals to 0. So I will just let cos x be the first graph. And then these two terms move to right side because 4 minus x squared be the second graph. So let y1 equals to cot x and y2 is the quadratic curve. Okay, but then when we need to sketch cotangent x, right, we need to refer to tangent because cotangent x is 1 over tangent. And now tangent graph. This is my tangent graph. Okay, so here is 2 pi. This is pi, and here is half pi. So this is 3 over 2 pi. Now, you need to show that there is a root in this interval. So therefore, I will just consider the first part of the graph. This is my tangent graph. Y equals to tangent x. Now, when you need to sketch cotangent, so you consider when x is 0. Okay, this is x. 0 and half pi. So for tangent graph, tangent 0 is 0. Tangent half pi, it tends to infinity over here. So now for the cotangent, cotangent is 1 over tangent. So 1 over 0, 1 over a small value, I would say some small value, it will be tends to a huge number. But 1 divided by a huge number tends to 0. Okay, and I can say that here increasing, here increase. So 1 over increasing is decreasing. So I get the idea to sketch a graph now, the cotangent graph. So that means now here my graph is Okay, let's say this is pi, half pi. So when half pi, I get 0. Okay, when x, I'll get infinity. Infinity, that means here from infinity drops to 0. That means it will be like this. It will not touch. Right? This is my graph. Cotangent. From 0 to half pi. And now I need to sketch this quadratic curve. So when y2 is 4 minus x squared, so we know that when x is 0, your y is 4. So let's say here is 4. We are not sure where is the 4. And then when y equals to 0, okay, I will get 4 minus x squared is 0. X squared is 4. X will be plus minus 2. So this pi over 2 is only 1.7. That means it will be here. Alright, so which means my another graph is something like this. Let's say this is 2. Let's say here is 2. Okay, this is y equals to 4 minus x squared. So from here, obviously, there is only one intersection point. Alright, that means now what to do is, you can just say, there is only one intersection point between two graphs. Okay, therefore hence cot x plus x squared minus 4 equals to 0 has a root or a real root, okay, in this interval. Alright, so this is the solution for the first part, whereby we use graph to show that there is a root in the interval, which means you just need to find out the intersection point. If there is one root, then there will be one intersection point. Okay, now B, show that if a sequence of values given by the iterative formula, this is a formula, if this formula converges, then it converges to a root of the equation in part A. So basically the root in the part A means the x, right? X in this equation. So which means this question is requested you to show from this formula until you are getting the equation. Okay, so which means now what to do is I will let x equals to tangent 1 over 4 minus x squared. So ignore all the subscript first. And then now be careful, we need to show this. Okay, which means I need to get cotangent x plus the quadratic. So which means firstly I will move the arctangent to the left side. It becomes tangent. So tangent x is 1 over 4 minus x squared. But we know that cotangent x is 1 over tangent x. So now I will just switch these two. Okay, so tangent x move down, the 4 minus x squared move to the other side. That means it will be 4 minus x squared equals to 1 over tangent x. And 1 over tangent x will be changed to cotangent x. And now when you compare with the equation in the part A, so first term cotangent x, second term x squared, third term minus 4. Which means to get that, just move all the terms on the left side to right side. Then I will be getting cotangent x minus x squared plus x squared minus 4 equals to 0. Okay, so this is the equation in the part A. So here we have shown the solution. Okay, now C, use the iterative formula in part B with initial value x0 equals to 0.5 to find the root of the equation correct to 3 decimal places. Give your answer of each iteration to 5 decimal places. Alright, so from here I will say my x0 is 0.5, xn plus 1 equals to arctangent 1 over 4 minus xn squared. Alright, so with the x0 I can find x1. So it means here I will write x1 equals to arctangent 1 over 4 minus 0.5 squared. And again, you have to leave your answer in radians mode. Use your answer, change the mode of the calculator to radians mode. Then here will be 0.26060. Okay, then now from 0.5 change to 0.260, so there is a huge difference. So now calculate x2. So when x2, it will be arctangent 1 over 4 minus 0.26060 squared. Then that is going to be 0.24904. Okay, and the x3, it will be arctangent 1 over 4 minus 0.24904 squared. Then this is 0.24868. Now when you compare three decimal places, okay, so I know that if I round up here, it's going to be 249. But then now I have to confirm with the next calculation. Then this is going to be 0.24867. So we check here, right? 3 decimal places, and now exactly the same, 248. Then now I will refer to the last one and do the round up. Okay, so now I will be getting 0.249. So x approximate to 0.249. Okay, so this is how we calculate the root. Alright, so that's all for the video. Thank you for watching. If you enjoy watching my video, please subscribe to the channel and share this channel to your friends. And also stay tuned for more upcoming videos. Thank you everyone. Bye.